morning, students. We have seen methods of preparation of amines. Today we are going to study some chemical properties, and before that we have to consider basicity of amines. In 11th standard you learn that acids and bases are classified into different ways, that is according to Arrhenius theory, Lowry-Bronsted theory, Lewis acid-base theory. According to Lewis acid-base theory, substance which is having ability to donate the pair of electron is said to be base. Here in ammonia, lone pair of electron is present. It can be donated to electron deficient species, that is BF3, and we get such complex. This bond form is called as coordinate bond. This is coordinate bond. Okay. So according to this Lewis acid-base theory, this substance is base. So ammonia is basic in nature. In another way, if we consider this nitrogen derivative, or we can say primary, secondary or tertiary amine, when it is treated with water, here if it has ability to donate the electron, this is base. Here water is having hydrogen, so hydrogen can be donated to nitrogen, and hence we can say this is acid. When this base and acid combines together, then this abstract one hydrogen from water and forms this conjugated acid. This is conjugated acid. Okay. So according to Lowry-Bronsted theory, we can say that this is base. So amines are basic in nature. So you have to remember why amines are basic in nature and give any suitable example. Then we can consider any suitable example, like when ammonia, instead of ammonia, if you take example, that is CH3NH2, when it combines with this HCl, it gives CH3NH3Cl-. Okay, so it abstract one hydrogen and form corresponding conjugate acid. Now, what is the strength, or we can say what is the order of this basicity of amines? Generally, these amines are having order of strength of basicity, that ammonia is less basic than primary amine, which is less basic than secondary amine, and exceptionally this secondary amine is more basic than tertiary amine. So this strength of basicity is expressed in different ways. For example, what are the factors which affects the basicity? Now expected and actual, these 2 points we have to consider. Now what is the factors which affects the basic strength? First one is plus I inductive effect. As you learn that plus I inductive effect increases, basicity increases. If we consider this, then this R group exerts plus I inductive effect, and therefore if this magnitude of R group increases, then basicity increases. Okay, so expected order of basicity is tertiary amine is more basic than secondary amine is more basic than primary amine, which is more basic than this ammonia, and this basicity is expressed in terms of conjugate acid. Means when this amines react with acid, it gives conjugate acid. This gives conjugate acid, and this conjugate acid is stabilized. If any substance is stabilized, any product is stabilized, then we can say this is a good method of preparation. here this is stabilized. This is reversible reaction. If this is more stable, then equilibrium is shifted towards the product side. Here, so according to this plus I inductive effect, as plus I inductive effect increases, basicity increases, and as magnitude of plus I inductive effect increases, then basicity also increases. And according to this, we can say that this tertiary amine is more basic than secondary amine, which is more basic than primary amine, which is more basic than ammonia. This is according to plus I inductive effect. So this is expected order of basicity. Then we'll actually this tertiary amine is less basic as compared to this. And that means there must be another factor which affect the basicity. And that another factor is solvation. So what is solvation? If we consider these conjugate acids form. So these are conjugate acids. These conjugate acids when added dissolved into the water, then this is stabilized by hydrogen bonding of water. Okay, so it is stabilized by intermolecular hydrogen bonding, and if it is stabilized by intermolecular hydrogen bonding using water, then it is called as solvation. So we can say that in case of primary amine, this solvation is more. Then consider secondary amine, RNR H plus. So this is again stabilized by water, that is intermolecular hydrogen bonding with water, but it is less stable as compared to this by solvation. Again for tertiary amine, it has only conjugate acid of tertiary amine, it has only one hydrogen, so it is solvated by only one molecule. So according to this solvation, we can say that this conjugate acid of ammonia is more solvated than primary amine, then secondary amine, and then tertiary amine. But actually, in case of tertiary amine, due to the steric factors, it is less basic as compared to secondary amine. So combined effect is this tertiary amine is having plus 3 effect, 3 plus inductive effect, but it is less solvated. Here in case of secondary amine, it has 2 plus I inductive effect, therefore it is more basic, as well as it is stabilized by solvation, and therefore this is more basic as compared to primary amine and more basic than tertiary amine. So we can say that here correct order of basicity is secondary amine is more basic than primary amine, which is more basic. The secondary amine is more basic as compared to this tertiary amine. So we can consider order of basicity is primary amine is less basic than secondary amine, and this secondary amine is more basic than tertiary amine. So this is correct order of basicity. So you have to remember, if question is asked, explain basic nature of amines for 2 or 3 marks, then you have to explain all these things. Okay, so write this.